Hello Gophers, welcome back to part 5 of our introduction to Go. In this video, we'll be learning about some commonly used packages. So let's start. Before we move forward, please do not forget to like, share and subscribe to our YouTube channel. And also press the bell icon so you don't miss on any new notifications from our tutorials. Topics that I'll be covering today are how to work with strings package, where you can have some manipulation on strings, working with math package, and working with datetime package. So now let's start by understanding some commonly used functions in strings package. Let's suppose I have a string 1 and a string 2 defined, which contains value hi there, and this is James. These are the two strings that I have in the two variables str1 and str2. I just want them to be in uppercase and want to print them or store them in some other string variable. Now how to do that? So we'll first have to import the package and now let's start and try to print fmt.println. Println is basically to print a line. It will not contain any line, any sort of percentage s or percentage d over here. Now let's say str1 comma str1. I'll print that directly and then also try to print it with string strings dot to upper, and let's run this program and see what happens. Okay, it says str2 is declared but not used, so I'll just, for the sake of program, I'll just print this as well so that it is not angry on us. Now if you see, on the first two lines I have got hi there, where it was all cases as I typed over here, and in the second where I gave strings dot to upper, all cases are there in upper. Now let's try to print the second string in title case, strings dot title. So this function will capitalize each first character of each word in the string. Now let's try and run this. Now you can see that earlier the string was only T and J were capital. Now when I use the title function, now I is also capital in this. So this is these are two functions. You also have a to lower function. Now let's title function, and let's say to lower function dot to lower. Now let's see, save and run this program. str2 will have three outputs. One is directly the string, second one is in title case, and third is in all lowercase. So these are the three basic functions that are there in string package. Now let's also go ahead and see how we can compare two strings. I'll declare str3 and str4 over here and assign two values like apple apple and pple apple. Both are same words, but if I do a fmt dot println and try to check if it is equal or not, and I'll give str3 double equal to str4. Now if I see and print this, I'll get a false, but eventually if you see these two words are actually equal, but this double equal to sign will also compare the case sensitivity. Now if you want a case insensitive comparison, then we can use a function that is there in strings package, strings strings dot equal fold, and pass in the two variables, and this will say this is equal or not. This fold means that the two variable will be converted to uppercase and then compared. So if you see, if we compare these two in all upper cases, then these two will eventually be equals. Now sometimes there might be a case where you want to see if there is a string contained in another string or not. Let's say I have string 5 and string 6, where string 5 is something that I need to check on and string 6 is something that I need to search for. So hello world, and I need to search hello. Now let's see if we can do this. Fmt dot println, let's say contains contains, okay, string strings dot contains. So in strings dot contains, the first value that you pass is the complete string in which you want to search the smaller string str6. Now I want to search str6 in str5. Now let's try and run this program. So it says it does contain he in it. Now let's try one more thing, if it is case insensitive or not. No, it's case sensitive. This contains will always have a case sensitive comparison and verify if the string does contain or not. If you want to do this case insensitive, then you need to do strings dot to upper or to lower, whatever you like to do. String 5 string strings dot to upper, I'll convert both to uppercase so that both have same cases. Now I'll try to run, then it will always give me whether it is case, whatever the case would be, it will always return me a result true because we have converted it to uppercase. So that's all for the string function. Now let's move forward to using math function. So now let's understand math package in Go. As other C style languages, Go also supports all the arithmetic operations that are there. For example, addition, subtraction, multiplication, division, or the remainder modulus operation. It also supports all the bitwise operations as well. Now let's first start by understanding how we can use the arithmetic operations in Go. Here I have a variable a1 and a2 which will have integer values as 11, 2. I'll try to print their sum in some variable and then print it to console. So a3 is equal to a1 plus a2. Now fmt dot print line sum of integer value is a3. Now let's run this program. It says sum is 3. Now let's try with a modulus operation. A4 is equal to A1 modulus A2. Now let's try and mod of int is A4. Now let's try and run this program. I've got mod of int is 1. That's correct because when you divide 11 by 2, you get 1 as a remainder. Now let's try to do some operations with floating variables as well. I have a floating variable f1 and f2 and f3 where I have given a value of 1.1, 2.4 and 3.6. Now let's try to add them up. F1, F2, F3. Now let's try to print them to console of float is F4. Here I have not given a comma. Okay, now let's run this. Sum of float is 7.1. Now, one more thing that we have learned about Go is Go does not allow implicit numeric conversion. Now that means that Go will not automatically convert an integer type value to a float value when we are doing any sort of mathematical operation. Let's see this with an example. Let's say I have a variable f5 which needs to have sum of a1 plus f1. Now let's see if we can print this sum of float and int. Now let's see if this is even possible or not. So it says mismatch type integer and float cannot invalid operation a1 plus f1 because it is expecting an float variable or you need to convert this to integer variable. So normally we'll go with an upper side conversion, that is to float 64. Now let's see the sum. Now if you see sum of float and integer is 12.1 because f1 was 1.1 and then 11. 12.1. That's how you do an uh, addition of two different data types in Go. Also, I need to tell you one more thing about math package. Now let's uncomment the import of math package. And I have a variable, say d1, which has a value of minus 12. I need absolute of this value. And absolute math.abs d1. Now let's see if we can even do this operation or not. It says cannot use d1 type integer as type float 64. Now all the variables that are to be passed in any functions of math package are to be converted to float 64. So to do that, I'll do float 64 conversion of numeric to integer to float. Now let's run this. I think I missed some part. Okay, I can save this part. Sorry. And I think I have missed one more parenthesis. Yeah, that's it. Okay. Now if you see absolute value is 12. So the thing that we learned about math package is all the variables that are to be there passed into any functions of math package are to be converted to float 64 and then only can be passed. Now let's also try and use one more function, that is power of math package. For example, I have a variable num which will have math.power. Now float 64 to then float 64 3. I am trying to get 2 to the power 3 in num. Now let's print this fmt println 2 to power 3 is num. Now let's try and print this. We have got 8 as an answer. One more thing that you need to know, in math package we have a math slash big subdirectory. Now what's the use of math.big? At times when you are doing some of the numerical operations, arithmetic operations with floating numbers, and those are to be very precise and you need precision. So at times this float addition will give you some uh, floating values, because in Go also, as other languages, float is saved as a binary format. So when the binary format is added, the precision is lost at some times. For example, num1, num2, num3. Now I have a value of 23.5, 45.1, and 56.3, let's say. Now I have num4, where I will have some as num1 plus num2 plus num3. Now let's print this fmt.println float sum is num4. Now let's try and print this thing and see if we get an accurate precision or not. If you can see, I was expecting a zero point 0.9 value, but the precision is lost and we have got this value. Now this can be disastrous when you are playing with very accurate values like currency values or any scientific calculations. This can be disastrous. So what we can do is, Go has also given a package called math.big. Now let's import that math slash big, and now I can create three variables, let's say, where fb1, fb2, fb3 of type, and the type would be big big dot float. The data type that is to be used is big dot float. Now to assign values to a big numbers, we need to use set float 64, and now I'll assign 23.5 to fb1, 45.1 to fb2, now 56.3 to fb3. Now I will also create one more variable where sum big of type big dot float. Now to add the 3, I need to call the function add of the big float variable, where I need to pass only two arguments, that are f1, address of f1b, fb2. Now to add more variables to sum b, I need to use the chaining mechanism. Add address of sum b, then address of fb3. Now let's print this. Print f sum of big number is percentage dot 10g, and I need to give address of sum b. Now let's try and print this. Now this prints exact value that we needed. Now if we would have not used this and we would have used simple print ln, now let's see what value would have been printed. This is again the same value that was there when we added some float values. So to get in precision of accurate value, we need to use the operator percentage dot 10g. This gives an precision of exact what precision we were using over here. You can learn more about the math package by going on the website of GoLang and referring to the packages of math package. Here you can find all the functions that are there in math package, which contains trigonometric functions as well. It contains logarithmic functions and many more functions. You can go ahead and explore this library. I'll put the link of this package in the description below. Now let's start by understanding one more important package that you often might be using, that is time package. Now let's suppose I need a variable to store a particular date, that is 31st December 2019, let's say. So let's create a variable named date, and to create a date variable we'll be using time package. So time dot date is the syntax. The first value that needs to be passed in the parenthesis is the year. Second is time dot the month, then is the date, then hours, minutes, seconds, milliseconds, and the time zone, time dot utc, let's say. Now let's try and print this. Fmt dot printf date was percentage s backslash n and date. Now let's run this program. Now it says the date was 2019 December 31st. Okay. Now let's also try to get today's current date time of the system. So now time dot now, sorry, time dot now. Now let's print this as well. Current date time is now. Now let's print this. So current date time is 2019 September 5, and the time is 26 minutes, 0026 minutes, and the time zone is IST, Indian Standard Time. Now I will also try to access only the year part, or if I need only the weekday part, I want to print only those aspects of my date. Now let's say I want to print weekday. Oh, today is now dot weekday. Now let's try and print this. So sorry, D would be small. So today is Saturday. Uh, Spelling. Pardon me for my spellings. Now let's also try to print some other aspects of the date. Let's say I want to print year, comma, month, and day. Year, comma, month, comma, day. Now let's try and print this.
So, oh, okay, I gave only one literal percentage v, percentage v. I need to print three values, so I'll give three literals. And now let's print this. So, year, month, and date. Year, month is September, and date is 5. We can also add date to our date part. So to do that, let's use the function that adds date to your any date time variable, and it will need, and the function will return a date again. So let's say tomorrow will be now dot add date. The add date function will be accepting three parameters. The first one will be how many years you want to add, how many months, and how many days you want to add. Now let's try to print this tomorrow. Now let's try and print this. Let's see. Tomorrow's date would be 6th September 2009. Sorry, 2020. So this is what we can use of date package. Date package has many more functionalities or functions that you can go ahead and read it on this article, where you can see what all things are there including in date. So you can have since, until, these are some functions, duration. If you want to see ticks, so what exact time, seconds, and things. At times you want to like see if what time it took for a function to get executed. Those things, new ticker you can use. So those parts you can go ahead and read it on this tutorial, and I'll put the link in the description of the video. Please feel free to comment us on the comment section below if you need a detailed description of each and every packages that we discuss, or any other packages that we even don't discuss, so that we can take those and we can create a video on those packages as well. Currently in this tutorial, I was just focusing on introduction to the commonly used packages so that you can start coding in Go. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.